6. Oh, another note I did, if you haven't already seen this, I did grade your quizzes. Grades are in the grade book as of Saturday. I do have some that still need to take it, and I like to pass quizzes back so you can actually keep them. But if you want to see your quiz, not just see your score, during work time you can let me know and I'll get your quiz out so you can actually see it before I pass it back. So 6.6a, rational exponents and radicals. This section practices how to work with expressions that have a rational exponent. And a rational number, again, is a number that can be written as a fraction. So a rational exponent is an exponent that is a fraction. Rational exponents imply radicals, or rather represent radicals. It's an alternate way to represent a radical. So we're going to see how to write expressions with a rational exponent in radical form or vice versa today. And then we'll still be simplifying those expressions using properties of exponents tomorrow. But you really want to have the understanding today that when you see a fraction as an exponent, what it actually means as a radical. So to start out, I have just an expression, b to the 1/2 raised to the 2nd power. So what I want to show you here, when you have a power raised to another power, what can you do with those exponents? When you have a power raised to another power, what can you do? Not add them. Multiply. Yes, multiply them. So this would be b to the power of 1/2 times 2. And 1/2 times 2 is just 1. So it's just b to the 1st power, or just b. So this is used as a way to show you why a rational exponent means a radical. So it says, since b to the 1/2 squared equals just b, we can conclude thus b to the 1/2 is a number with a square equal to b, so therefore b to the 1/2 must equal the square root of b. They must be the same thing. The reason why, so we just saw that b to the 1/2 squared is b. We also know that if we take the square root of b and square it, the square root and the square cancel out, and that is also just b. So they're making the conclusion then, if both expressions squared equal the same thing, the two expressions must be equal to one another. So if you see something written to the 1/2 power, that means it's the square root of that quantity. Okay, so then I have two key concept boxes before we actually get into some examples of rewriting. And this is understanding what a rational exponent means. So the first key concept box is if you have an expression in the form of b to the 1/n. So your numerator of your fraction would be 1. So it says for any real number b and any positive integer n, b to the 1/n is equal to the nth root of b. So as we saw up here, b to the 1/2 is the square root of b, because we know the index of a square root is 2. So that denominator is the index of the radical. It does go on to say except when b is less than 0. So if b was negative and n was even, then you'd have the even root of a negative number that would be imaginary. So that is just stating that here. If b was less than 0 and n was even, then a complex root may exist. You'd have an imaginary root. But it's showing how to rewrite 27 to the 1/3. That would be the cube root of 27. So that denominator in the fraction is the index of the radical. We know the cube root of 27 is then 3. So it's rewriting it as a radical because we've been working on evaluating and simplifying radicals. And then they have negative 16 to the 1/2 would be the square root of negative 16. And we know that's imaginary, so that's 4i. So then, if you have an exponent as a fraction where the numerator is not 1, that's what is stated in this box. So these rational exponents, this is a more general case. Up above is more specific. So for any real non-zero number b and any integers x and y with y greater than 1, if you have an expression of the form b to the power of x over y. This is the root of b with an index of y and a power of x, and it can be written one of two ways, so this first way or in the next line, you can see it's the root or the radical b with index y, and then the entire quantity is raised to the power of x. So what I want you to understand though is, again, the denominator is still the index of the radical. The numerator of the fraction is the power that b is being raised to. So up above, when we had a numerator of 1, this rule still applies, but if it's just to the first power, it's not necessary to write it in. So the denominator is the index, the numerator is the power it's being raised to. So it shows examples. If you have 27 to the 2/3, this would be the cube root of 27 squared. So you could take the cube root of 27, which is 3, and then square it, so it simplifies to 9. Negative 16 to the 3/2 would be the square root of negative 16 cubed. So they're taking then 4i cubed to get negative 64i when it's simplified. So in example 1, these are just rewriting the expressions in the alternate form. So if it's an exponential expression, writing it in radical form. If it's a radical, writing it as an exponent. Just making sure you understand how to rewrite them. So if we look at a, it says write a to the 1/5 in radical form. So because we have a denominator of 5 and a numerator of 1, this would just represent the 5th root of a. And if you put the 5th root of a to the first, that's fine. But just the 5th root of a would be the radical form. And then for part B, we have the 8th root of c. So writing that in exponential form, so our index is 8. The power on c would just be 1. So this would be c to the 1/8 power. So the index of 8 is the denominator in the fraction. The 1 would be the numerator. Okay? Again, just knowing how to go back and forth. So then for the next one, if you have d to the 7/4, so the 4, now because our numerator is not 1, the 4, the denominator is the index. The 7 is the power it's being raised to. So this would be the 4th root. I'm going to show you two ways to write it. The 4th root of d to the 7th, so it can be written that way. Again, the 4 is the index, 7 is the exponent. Or another way to write it that means the same thing is if you wrote the 4th root of d and then raised that entire quantity to the 7th power. Either one of those forms are, or they're both correct. So however you write it, you don't have to write both, but you have to write one or the other. And then if we have the cube root for part D, the cube root of c to the -5th, writing that in exponential form. So the index of 3 should be the denominator, the -5, that power c is being raised to, should be the numerator. So this would be c to the -5/3 power. Okay, so I'd like you to, I know the E here got cut off by the hole punch, but I'd like you to do the next two. Just rewrite. These are quick, so I'm not going to walk around, but rewrite them, and then when it looks like everybody's done, I'll show the answers, check what you have, make sure you're rewriting them correctly. All right. Looks like we might be done. So double check what you have. E, a to the 1/7 is the 7th root of a. If you have the 7th root of a to the first, that's fine. And then the square root of w is w to the 1/2. So remember, the index on a square root is 2. And that w doesn't have a power, so it would just be 1. Any questions on writing from one form into the next? We're still going to be practicing it in the next examples, but questions at this point? All right. Then for example 2, here you are evaluating each expression. So when it says to evaluate each expression, your answer should just be a number. So it shouldn't include radicals. It shouldn't include exponents. You should be evaluating it to get a number. And I want you to leave all of your answers as fractions when necessary. So when I give you this type of problem, I am not just looking at your answer. I'm going to be looking at how you got your answer. So I want to see your process for rewriting these. I do not just want you to type into your calculator and then give me what the calculator says. So if your calculator gives you a decimal, I want you to give your answer as a fraction, because I want to see that you know why it equals that decimal. So when we have for A, negative 3,125 to the negative 1/5 power, so here you have to remember, when you have a negative exponent, we shouldn't leave negative exponents in our answers. How do you make a negative exponent positive? So this is thinking back to properties of exponents. How do you make a negative exponent positive? On the other side of the fraction, so like bring it down? Yes, so remember if we think of this as being over 1, you make it positive by taking the reciprocal or moving it from the top to the bottom of a fraction. So this would be equivalent to 1 over negative 3,125 to the positive 1/5 power. So when you're actually evaluating, you want those exponents to be positive. The numbers themselves can be negative. And then I want to see, since we've spent time learning how to simplify radicals or evaluate radicals with our calculators, I want to see the radical form for these. So the 1/5 power would be written how as a radical? So I'd have 1 over, I know I'd have the negative 3,125 in the radical. What does the 1/5 mean? The 5th root, yes. Okay, you can have a 5th root or an odd root of a negative number. Your answer will not be imaginary here. So then this, I don't expect you to just know the 5th root. You can find that using your calculator. Does anybody find what the 5th root of negative 3,125 is? Negative 5. So this would be 1 over negative 5 or negative 1/5. And that's what I mean. If you just typed in the beginning expression into your calculator, you would get negative 0.2. I want you to know why the answer is negative 0.2. Otherwise, that means nothing to you. Okay, so this is what I'd be looking for. How do you rewrite it in order to evaluate? So then for part B, we have 256 to the 3/8 power. So the power is positive. We don't have to worry about taking the reciprocal like we did for A. But we can rewrite this as a radical first. So I would write this, I know this is going to be the radical of 256. The denominator is 8, so it's the 8th root. How I usually work through these is I would take the 8th root and then take that entire quantity and raise it to the 3rd power. So I choose this notation to write it. Not that you couldn't use the other notation with the cube just on the 256. But this way, I would find the 8th root of 256 first. Can somebody tell me what the 8th root of 256 is? 2. And then I would take the 2 and cube it. So my final result is 8. But again, that way, if you just typed in your calculator the beginning expression and you get 8, you know why is it 8. Okay, so I want you to work through part C and D, evaluate those expressions, but follow that same process of rewriting them as radicals so that you understand why you're getting the answers you're getting.
I'm so confused. Probably one, like, I had one problem, and then I was put this in
This one was still negative.
No, I'm gonna trust you right now, because I go down to the I'm getting there. Alright.
Yes.
And then, I'm confused because the little negative sign here.
Well, I'll explain it to everybody. It should be positive. Are you wondering why?
Yeah.
Okay, double check. Double check. C should be positive 1/7, and then D should be 4. So I want, if you are confused about for A and for C, because A we had negative 1/5. So when you have a negative exponent, by bringing the term to the denominator, you make the exponent positive. So that gets rid of that negative. The reason A was still negative is because the 3,125 was negative. So with C, you just have 49 to the positive 1/2, which is the square root of 49, which is positive 7. Does that clear it up, Lily, why A is negative, C is positive? Okay. It's because, yeah, the base, for A, the base was negative. That's why it stayed negative, yeah.
I guess.
Okay. Well, with the practice, if you still have questions, let me know. The last set of examples, and some of you are working ahead, which is fine. Just double check that you have the right answers. You need the formula given above. It's not a formula that you have to memorize. But it says the formula capital C equals lowercase c times the quantity 1 plus r to the power of n, can be used to estimate the future cost of an item due to inflation. Capital C represents the future cost, lowercase c represents the current cost, r is the rate of inflation, and n is the number of years for the projection. So then you're using this formula in both examples 3 and 4. So for example 3, it says, suppose a video game costs $390 now. How much would the price increase in 6 months with an annual inflation rate of 5.3%? Okay, so if we look at our formula, I'm just going to rewrite that. Capital C equals lowercase c times the quantity 1 plus r to the n. We're obviously substituting in the values we are given into the formula, but we have to know where to substitute them in. So it says, suppose a video game system costs $390 now. Where would you substitute the 390 in? For which variable? What variable would 390 be? Which one? The lowercase c. So I'm going to have 390 in for lowercase c. It says, how much would the price increase in 6 months? So you're looking for uppercase c. You're looking for the future cost because you want to know how much the price would increase. And it says, how much would it increase in 6 months with an annual inflation rate of 5.3%? So I know I'm going to have 1 plus, I should have something to substitute in for r, and then I should have something to substitute in for n. So r is the rate of inflation. That's the 5.3%, but make sure when you substitute in a percent, you are substituting in the number that would represent the percent. So 5.3% is really 0.053. You'd have to divide 5.3 by 100. So this is the value you should substitute in for r, not 5.3 itself. And then if it wants how much the price would increase in 6 months, and n is the number of years for the projection, what would n be? N would be 1/2, because it's 6 months is half of a year. Okay, and then this just gets calculated using your calculator. Depending on your calculator, I know some, well, you know your calculators. Some calculators you have to type things in differently. If you have one like mine, I know you can just type it in the way that it's written. So careful how you're typing it in, though. It would be 390 times, in parentheses, 1 plus 0.053, close the parentheses, and then I can raise it to the 1/2 power. I'm just going to type in 0.5. Or you could type this in as a square root. And here we have 400.201572. We're dealing with money. So the future cost is 400 point, it makes sense to round money to the nearest cent. So $400.20 is the future cost. But then it doesn't ask for the future cost. So if you go back to the problem, it says, how much would the price increase? So what would we still need to do before we answer the question? Yes, so the price would increase if we take $400.20 and subtract the original, which was $390. Then it increased by $10.20. Okay, so make sure you are going back to actually look at what the question asked. and not just saying, oh, I found the future cost, that's my answer. This wanted how much the cost would increase. Okay, so I want you to work through example 4 if you haven't already, or maybe if you had done both example 3 and 4, just double check that 4, your answer makes sense. You actually answered the question. In a minute here, I'll come around to check, and then I'll pass out your assignment as well that you could start working on. The assignment, like I said, does include practice just from 6.5 with simplifying as well. So you can get some extra review for that.